This video will cover section R.4, and this section is on factoring polynomials. Now when you're factoring polynomials, one of the first things you want to do is look for the greatest common factor. Alright, and the process of finding polynomials whose product equals a given polynomial, alright, is called factoring. Alright, this is where we're finding, I'm going to give you a polynomial, which remember is addition and subtraction of terms. Alright, and we're going to look to see what did we multiply to get that polynomial. That's what we're trying to find when we're factoring. Alright, a polynomial with variable terms that cannot be written as a product of two polynomials of lesser degree, alright, is a prime polynomial. So if you go through the process and find that it cannot be factored, then we say that polynomial is prime. And that's what we would write as our answer, prime. Alright, a polynomial is factored completely when it is written as a product of prime polynomials. Alright, so that just means if you think back to section R.3 when we were multiplying polynomials. Remember, binomial times binomial. And so a polynomial is factored completely when all of the factors cannot be factored any further. Alright? Now, as I mentioned earlier, one of the first things you want to do when factoring is to look for the greatest common factor and go ahead and pull it out. So we're going to look through a couple examples on how to find the greatest common factor. And so remember, factors are things that are multiplied. Anything being multiplied is a factor, and the answer you get from multiplication would be a multiple of those factors. Alright, so what we're looking at here is 6a squared minus 18a to the fourth. And we're looking for what factor, or what can I multiply to get 6a squared, and I can use that exact same thing, one of those factors of 6a squared, to get 18a to the fourth. So what I'm going to do is look at the factors of 6 and the factors of 18, and I'm looking for the greatest or largest one that appears in both lists, or that is a factor to both 6 and 18. So I'm going to list the factors of 6. Now if you'll always start with 1 times 6, and then work your way up, once the factors start to repeat, you know you've listed them all. If you're just randomly listing them, then you're just going to have to maybe hope that you have the right ones. But if you'll do it this way, you'll know that you've listed them all. So 1 times 6 makes 6. The next number up from 1 is 2. 2 times 3. The next number up from 2 is 3. 3 times 2 makes 6. And notice here the factors start to repeat. Alright. And so that tells me I have listed all the factors, 1 and 6 and 2 and 3. Next I want to list the factors of 18. Starting with 1. 1 times 18. 2 times 9. 3 times 6. Then I try 4. It won't go into 18. 5 won't go into 18. And then the next number is 6. I already have it listed. This is the point they start to repeat. I know I'm done. Alright, so when I look at the factors of 6 and the factors of 18, the one that is largest, they have a couple in common. They have a 1, a 2, a 3, and a 6 in both lists. But the largest of those that are in both lists is the 6. So they have a 1, they have a 2, they have a 3, and they have a 6 in common. The largest of 1, 2, 3, and 6 is 6. That is my GCF. Okay, so the GCF, alright, is 6. But I also have some letters. Now when it comes to letters, what you want to do is look and find what letter or letters appear in every single term. So for the letter or variable GCF, I'm looking for what letter or possibly letters, what letter or letters appear and it has to be in every single term. Right, in every term, those are going to be common, and then the GCF will be we're going to use the smallest exponent. On that letter or letters. Okay? So, with that being said, when I look at the two terms, I have A and an A in both. That means A is common, alright, and the smallest exponent is 2. That means there are 2 A's common to both of those terms. Alright, now that's the GCF, but I want to know what times 6A squared will give me these two terms. Alright, so the way that I find that, you might can just do it in your head and that's fine, but if you can't, you take each term and divide it by the GCF. So I'm going to say 6A squared divided by 6A squared. Here's where some of those exponent rules are going to come in. But if you remember, anything divided by itself is 1. So I'm going to write a 1 here. Minus. Then I'm going to come over here and say 18A to the 4th. Divide it by my GCF. Alright, and 18 divided by 6 is 3. A to the 4th divided by A squared is A squared. So I'm going to come over here and write that. Alright, now I have two factors, 6A squared and 1 minus 3A squared. And if I take 6A squared and I distribute it into those parentheses, 6A squared times 1 will give me 6A squared, and 6A squared times negative 3A squared will give me negative 18A to the 4th. Alright, let's look at letter B. We're wanting to do the same thing, find the greatest common factor. Okay, so I can do that numerically, and possibly there may be a variable GCF, so I have to look at both. Alright, so when I look at the numbers, I have 14, 28, and 21. So if I were to list all the factors of 14, 28, and 21, I would find the largest one they have in common is 7. Alright, then when I look at the letters, there's an X and a Y in the first term, an X and a Y in the second term, and an X and a Y in the third term. So that means X and Y are common. The GCF will be the smallest exponent on each letter. So on the X, I have a 3, 2, 2. The smallest one is 2. And on the Y, I have 2, 3, 2. So the smallest exponent is 2. Alright, so 7x squared y squared is my GCF. Alright, so now I'm going to take 14x cubed y squared and I'm going to divide it by my GCF. And you might want to go off to the side somewhere and do that on the side of your paper. Just make sure you keep it. Alright, so 14 divided by 7 is 2. X cubed divided by x squared is x. Y squared divided by y squared is 1. Alright, and I'm not going to write a 1 there because 2 times 1 is 2. Alright, you could kind of say they cancel each other out if you wanted to. Alright, then next I have 28. Let's do it on here. 28 x squared y cubed divided by 7 x squared y squared. 28 divided by 7 is 4. X squared divided by x squared leaves x to the 0 or 1. 4 times 1 is 4. Y cubed divided by y squared leaves y. And we'll say plus 21x squared y squared divided by 7x squared y squared. 21 divided by 7 is 3. X squared divided by x squared, give me x to the 0 or 1. Y squared divided by y squared, give me y to the 0 or 1. And 3 times 1 is 3. Now you can check your answer by taking your GCF and multiplying it back times each term and verifying that it will give you the problem that you started with. Alright, lastly, alright, remember anything that's being multiplied together is a term. So when I look at this, this is 24 times the quantity x minus 2 cubed. So 24 is a factor, and x minus 2 cubed is a factor. Alright, and so since they're being multiplied together, this whole thing right here is one term. Then, same thing here. This whole thing is one term. Same thing here. This whole thing is one term. Alright, so it's a trinomial. Alright, so what I'm wanting to do is factor out a common factor. So I'm going to look at the coefficients 24, 16, and 6 and see if they have anything in common. And the largest one they'd have in common, if I were to list them all out, would be 2. Alright, now, x minus 2, you can't split those up because they're in parentheses together. Alright, but if you look at each term, notice that there is an x minus 2 in each term. Alright, the smallest exponent on that x minus 2 is 1. Alright, so if I pull out 2 times x minus 2, here's what I'll have left. 24 divided by 2 is 12. Alright, I took out 1 x minus 2. So here that'll leave me x minus 2 squared. I took one of the x minus 2's away, leaving me only 2. We'll say minus 16 divided by 2 is 8. I took one of the x minus 2's, leaving me only 1. And then we'll say 2 divided by 6 is 3. There's only one x minus 2 and I pulled it out, so that leaves me just 3. Now if you're working problems in your book and you get to one like this, it may go ahead and expand it all out. Go ahead and multiply everything out, but for me, this answer right here is sufficient.